Okay, so today we're going to take a bacterial culture, so this is Hope. We're going to perform a bacterial culture and sensitivity on the sample that she's giving us. So I have my agar plate here, and we also have our sterile culture and sensitivity tube that we're going to use here. So for the sake of this video, I'm going to take a swab of the inside of Hope's mouth along her gum line and her teeth. And hopefully that'll provide us with a good bacterial growth sample. So we'll go ahead. So you want to try to keep this sterile. So we're going to just only touch. Go ahead and open this guy. So we're just going to take our sterile swab. Okay, Hopi. And we're just going to take the inside of Hope's. Good girl, you are such a good girl. See that? And we're just gonna take a swab along her gum line here. Oh, it tastes funny, doesn't it? Good girl, Hope. Okay. And we're then gonna take our agar plate. Oops, wrong side. We're gonna take our agar plate, being careful not to touch anything else, and we're gonna do kind of a streaking single layer motion across, and you can go in different quadrants. So we'll just kind of go good girl. Just kind of like so. Kind of go in the different quadrant over here. And you want to do your best to try to do a single layer roll. Oops. And we'll just do one more quadrant on our agar plate over here. Oops. It's hard to just kind of do a nice single layer roll. Okay. Okay, so the next thing we're going to do is we're going to set our swab aside. We no longer need that, so we can discard it. We're going to place our lid back on. The next thing we're going to do is we're going to incubate our bacterial sample at 98.6 degrees Celsius. So you want to use an incubator, and then we will check it again tomorrow and note any bacterial growth. So we'll go ahead, take this and place it in our incubator, and you wouldn't want to have it above that temperature. The reason being is bacteria actually can't grow above that temperature. So you do want to make sure your incubator is at a good set temperature. Okay, so now that it's been 24 hours, let's go ahead and take a look at our bacterial growth on our agar plates. So this is our sample that we had labeled here. So this was Hope's gingival oral sample. So we took a sample along her gum line. I'll go ahead and show you what we have here. So we have a pretty significant bacterial growth. So that growth is characterized by all these little white dots. These are bacterial colonies. And you can see it appeared in all four quadrants, which kind of tells you that, you know, she does have quite a bit of some sort of bacteria in her mouth, which is not surprising given dogs' mouths just have bacteria. So I did take one other additional sample. So I also took feline, oral, and gingival samples as well. So these two quadrants right here, so we do kind of place our samples in single rows, kind of monolayer single rows, and then you want to do it in kind of quadrants like this. So I did 3 quadrants for this one. So these two samples right here, this is kind of the smaller ones. This was a feline, one-year-old feline oral gingival sample. And this one down here is the same, but in a 15-year-old feline. So kind of interesting. So there's actually quite a bit more growth on the 15-year-old sample. Not surprising given the fact that this cat had quite a bit more periodontal disease. So pretty cool. Okay, so we'll go ahead and talk about the common. We did have both our samples labeled, by the way, so you want to make sure that your sample is labeled with the name, date, patient name, just like we have. I also put the time as well. That just really helps, you know, helps us chart our progress here as far as our bacterial growth. Okay, so we'll go over some common types of oral bacteria that you'd see in both canines and felines. So Streptococcus, so this is a bacteria that's found, different strains, but very similar Streptococcus in both canine and feline mouths. So it's one of the top for both. That's just kind of an example. You can kind of see like that big, it looks very similar to what we kind of just saw. So little, tiny little white dots. Move on. Staphylococcus, this is for dogs. So Staphylococcus is a very common strain that you'd see in an oral sample from a dog. So it has kind of a similar appearance. It almost looks a little, the little white dots look a little larger and a little thicker to me. Go over our next. Okay, so Pasteurella canis. So this is reported as one of the top bacteria that you're going to find in, say, like a dog bite wound. So this is a very common oral bacteria in dogs. So if not the most common. So looks really similar to what we just saw. I'm a little suspicious that it might be something like this or strep. Okay, and then in felines, a different strain, but they also experience Pasteurella as well, Pasteurella bacteria in their saliva. So that's a common bacteria that you would see in cat bite wounds. Okay, so the next thing we're going to do is we're going to go ahead and apply our antibiotic discs to our samples. Okay, so the antibiotics that I chose penicillin, gentamicin, and doxycycline. So these, actually all of the bacteria that I just was talking about, supposedly all those three types of bacteria, Streptococcus, Staphylococcus, and Pasteurella, seem to be all sensitive to amoxicillin, penicillin antibiotics. So I'll be curious to see. My suspicion is that these are growing one of those bacteria. So we'll go ahead and I'm going to start with the penicillin. We have our little disc here. Okay. I'm going to put it on these can be a little tricky to get on here. Okay, so the next thing I'm going to do is I chose gentamicin as well. So we're going to stick this on another quadrant here. And I'm going to make sure to take note of where I'm putting these guys so that way I don't get them confused. These antibiotic discs look very similar. Okay. Also put gentamicin over here as well. Okay, and then the last thing is we're going to use a tetracycline, some doxycycline, and we'll put it on another quadrant. I'm going to do this really carefully. Okay, come here. These little guys can be kind of hard to pick up. Okay, we'll stick our final doxycycline right there. So I just kind of placed discs on different quadrants so I can kind of keep track of what is where, but I'm also going to take note. The next thing we're going to do is we're going to incubate this for 24 more hours in the right environment. And we're going to come back and take a look and see if these guys are sensitive to any of these antibiotics we placed. Okay, so now that it's been 24 full hours, we're going to go ahead and evaluate our bacterial cultures and take a look and see what, if any, effect has occurred from our antibiotic disc placing. So the first thing I'm going to do is I'm going to look at, this is our sample from Hope. So this is our gingival oral sample. So we took a sample from along her gum line, and we did see pretty significant growth after 24 hours. So let's go ahead and take a look. Let's go ahead and take a look and see what we have here. So the antibiotic discs that we placed contained, if you remember, we had penicillin, we had gentamicin, and we had doxycycline. So we'll go ahead and take a peek. Okay, so that's kind of what we're looking at here. Honestly, I do not see an awful lot of sensitivity to any of these. If I were to say one out of any of them, I would say penicillin. We actually do see a small ring around the penicillin. Whoops, you see that there? So you'll see what I'm talking about here. There's a tiny, tiny small outer ring that we are looking at here. So I think that this this particular type of bacteria is sensitive to penicillin. It's hard to say, but if I were to guess, I'd say that's what's occurring. I believe that we actually have a sensitivity, a light sensitivity to the penicillin. In certain bacteria, you may, certain bacterial cultures, sometimes you may want to incubate them for longer. It just kind of depends. But since this is only 24 hours out, it's hard to say if this would likely continue to show sensitivity if we were to incubate it longer. So gentamicin, I'm going to say is negative. Doxycycline right now, negative. So that's kind of our 24-hour results for this. So I'll kind of explain what you would see. I'll draw a picture, and I'll kind of explain what you should see with significant bacterial or antibiotic sensitivity. So I'm going to just kind of draw a picture here. Okay, this is kind of just a photo of what you'd kind of expect to see with sensitivity to antibiotics. So let's pretend this is our agar plate. You see these dark circles, these are our antibiotic discs. Now, if you were having sensitivity to them, essentially you'd see kind of an outward growing circle, essentially killing off that bacteria in kind of an outwards motion like that. So you kind of see a clearing around the bacteria. So again, we'll go ahead and go back to our bacterial culture here. So let's take a look. Yep, this is the one. So again, you can sort of see that occurring here with this penicillin. You can kind of see that there, hopefully. But I do not appreciate that with any of these other antibiotic discs. So if I were to guess, I'd say this particular type of bacteria from Hope's oral cavity is likely sensitive to penicillin, which actually is interesting because the types of bacteria commonly seen in canine mouths, one of the top things that studies show, one of the top antibiotics that studies show are sensitive is, one of them is penicillin, and actually I think that was one of the top ones. So that's pretty cool. So that kind of concludes this bacterial culture task.